My personal favorite way of solving systems of equations is elimination. Sometimes it's easier to do them substitution or even graphing, but elimination with linear functions seems to work really quite well as long as you have the right setup. So our outcomes today is to solve systems using elimination and then maybe try a worded problem that looks like that. Okay, so the key in using elimination is to manipulate your equations into a format that you want. Initially, what you want to have x's and y's on both sides of the equation. Also, what you want is you want to have the coefficient of either x or y to be exactly the same. In this case here, coefficients of x are both 1, coefficients of y are both 1. I guess one's 1 and one's -1, but the numbers are the same. Then what you do, you either subtract or add the two equations, and this is where it gets a little bit funny, something that you may not have done before, but you either add or subtract the equations based on whether your coefficients have the same sign or not. So if they have the same sign, you want to get rid of them, you'll subtract them. If they have opposite signs like these two, to get rid of the y's, you would add them. So let's try that with this one. It'll take you a time or two to get the feel of it, but we'll do 3 examples here. So let's solve this system. Again, when I solve, there's 2 lines. I'm looking for a place where they cross. Okay, I notice that the x's both have a 1 in front, and they're both the same sign. So I'm going to subtract the equations. Notice I put a circle around the subtract just to indicate to me that it's not a negative x. I'm actually subtracting these two equations. So if I go x minus x, I get 0x or nothing, hence the name elimination. Y minus a negative y is a positive 2y. See how you might get tangled up on that? You have to be careful on your toes. Y minus a minus y is 2y. 5 subtract a negative 3 is a positive 8. Again, you have to be careful there. But notice what I have immediately. I've got a simple linear equation. I can solve that, divide both sides by 2, and I come up with y is equal to 4. Now, simply plug that back into one of the equations and solve for x. So I'll pick the first equation, and I'll substitute my 4 in, whoops, that's a plus, my 4 in for y. And if I move the 4 to the other side and subtract, I get a 1. So, the point at which these two lines cross is the point 1 and 4. If I were to plug a 1 and 4 in here, you'll notice that it also solves this equation. This point must be good for both of those equations. One thing that I really like about system of equations is when you have your answer, there's lots of ways to check. Just take these two numbers, plug them back in for x and y here, see if it's true. Plug it back for x and y, see if it's true. And if it's true for both of those, I can be fairly confident that my answer is correct. Let's try another one. Solve by elimination method. Okay, so I have my equations, 2y plus x equals 1. Notice I have x and y on both sides here. That's looking good. If you're a purist, I don't know if purist is the right word, but I like my letters in the right order. So I'm just going to change these. X plus 2y equals 1, and a minus 2x plus y is equal to 8. There. All I did was change the order of x and y. So I have my variables on the left, numbers on the right. This is good. But what else did it tell me to do? And ensure that one of the variables, either x or y, has the same coefficient. Okay, well here the x's coefficients are different. Here the y coefficients are different. So it's telling me to make them the same. Well, I can use that property where if I multiply one side by something, I multiply the other side by the same thing, and the equality remains. I can do that here. Let's try maybe making these coefficients for x to be the same. So let's take this first equation. So I'm going to take equation number 1, and I'm going to multiply it by 2 so that the numbers on front of the x's are the same. Okay, so x times 2 would be 2x. 2y times 2 would be 4y. And don't forget this guy, I have to multiply it by 2 as well. So my first equation is now morphed into this. All I did was times everything by 2. Now let's write down the second one below it. Minus 2x plus y is equal to 8. Now I have the coefficients the same. This time the signs are different, so instead of subtracting, I'm going to add these two equations. So I'm going to add them. Okay, so 2x plus a negative 2x is 0x, hence the name elimination. X's are eliminated. 4y plus y is 5y. 2 plus 8 is 10. Gotta like it when they come out like that, eh? Divide both sides by 5, you get y is equal to 2. And my last step, of course, is to plug that 2 into either here or there. It's nice, like I said before, to plug it in both places. So I'm going to substitute a 2 into this equation here. So I'm going to plug a 2 in everywhere I see a y. That should have been equal 1. Equal 1. So it's 4 plus x is equal to 1. Subtract 4 from both sides. I get x is a negative 3. So my solution to this system, the point at which those two lines cross, is the point minus 3 and 2. Again, you can check that in both equations. I've graphed it down here too. Let's just see if that's where they cross. 1, 2, 3, up to, sure enough, they cross at minus 3 and 2. I could do that same question in the last section. Okay, let's try another one. Oh, a worded problem. Today I ate 1,500 calories. I ate twice as many calories at meals than I did for snacks. Oh, so I had meals plus snacks were 1,500 calories. Then it says I ate twice as many calories at meals than I did for snacks. So the number of calories for meals were equal to the snacks times 2. Is that right? I ate twice as many calories at meals than I did for snacks. So if I take the snacks and times it by 2, I get meals. Yeah, that's right. So here I have two equations. Both of them have an m and an s in them. And so I can solve the system, and that'll tell me what m and s is. Okay, initially notice that they're not all the same, so I need to make them the same. Or in other words, I need to put all the variables on the same side. So I'm going to have m minus 2s is equal to, oh, there's nothing over there, 0. Now, so I have a ms, I'm good there. I need to get a coefficient the same. Hey, both of these are the same. So I can take these equations and subtract them. So let's go subtract. So I'm going to go m minus m, nothing, cancels. S minus a negative 2s would be 3s. Careful with that there. 1,500 minus nothing is 1,500. Now I have a nice little equation. Divide both sides by 3. I get s is equal to 500. So if s is 500, now I can plug that back into this equation and solve for m. So s is 500 equals 1,500. Subtract 500 from both sides, and as we supposed, m is 1,000. So it looks like I ate 500 calories in snacks and 1,000 calories in meals. So in this section, we looked at the method of elimination to solve system of equations. Again, it's my personal favorite. I like this one. However, it's essential that you're good at all ways of solving system of equations, because there will be some equations, systems, where you're sort of forced to use substitution or you're forced to use elimination. So you need to be able to look at a question and say, oh, that one lends itself to using substitution as a better method. Try some questions, give me a holler.